we're going to work a problem from section 4.1. It's number 42 on page 114. I encourage you before watching this video to attempt to work problem number 42 on page 114 before listening to the explanation. The situation we have are two people on a ice skating rink, which for our purposes is a frictionless surface, so we can neglect the force due to friction. Our two ice skaters are Joyce and I believe it would be pronounced Ifao. So person A and person B. Joyce pushes, in other words, applies a force to her friend, and that force has a magnitude of 5 newtons, and it's in the positive or the right direction. Her friend Ifao has a mass of 40 kilograms. Our question is to find what is the acceleration that Ifao, her friend, undergoes due to this force applied by Joyce. So our situation is one in which we have a force applied by Joyce onto her friend Ifao. That is the only force that we're considering for her friend. So this happens to be the net force that's being applied to Ifao. If we were to look at the sum of all the forces that are acting on Ifao, that would be the only force. So because this is the net force, because it's the sum of all the forces, it's the only one, we know that that is equal to the mass of Ifao, of our object that's undergoing such a force, times the acceleration. That's Newton's second law for us, right? Newton's second law. If we wanted a simplified version of what we have going on here with the image, we would draw a free body diagram. Our circle, our dot here, would represent the free body diagram. Our force vector would be represented by an arrow in the direction that the force is applied. There's our force vector that's acting on the friend. I'll label that force this way. Very simple free body diagram. Now referring back to Newton's second law, we see that the sum of the forces, that one force that's acting on the friend, is equal to her mass, and it results in some acceleration. And this is the relationship that we see between the force that's applied and the acceleration. The force that's applied and the acceleration that the friend will undergo is due to the mass. That's the tying relationship between the two. All right. Well, if the net force is that of positive 5 newtons, and the mass of Ifao is 40.0 kilograms, this helps us find, well, what the acceleration would be, at least the magnitude of the acceleration. To solve for this, we just need to divide and isolate the magnitude of the acceleration by dividing both sides by 40.0 kilograms. On our right-hand side, all that's left is our magnitude of the acceleration. On the right is 5 divided by 40. We have two significant figures here, the 2 and the 5.0. 40.0 has 3 significant figures. So our resulting calculation is 0.13 meters per second squared. And because it's in the positive direction, because the force is in the positive direction, then the acceleration is also in the positive direction. So we'll note that it is positive 0.13 meters per second squared. As a final point of emphasis, because Newton's second law says the force vector is equal to the acceleration vector times the mass, both the acceleration and the force vector are in the precise same direction. because the force is to the right or positive, then the acceleration is to the right or positive. All right, thank you.